So in this video, we're going to use the product rule to help us find the equation of a tangent line to a graph. So this is something we've done already. We've found equations of tangent lines to graphs of functions. So just reminding ourselves, if we're after the equation of a line that is tangent to a specific function, and in this case it says, here's a function r of x, find the equation of the line that's tangent to r of x when x is equal to -1. There's really two things that we need to know. We need to know the point on the graph of r of x that corresponds to x equaling -1. So we need to know the ordered pair -1 r of -1. And we need to know the slope of the tangent line when x is equal to -1. And the slope of that tangent line is just going to be r prime evaluated at -1. So we need to know a point on the line and the slope of the line to find the equation of a tangent line. So in this case, my first step would be to find the point on the on r of x that corresponds to x equaling -1. So I would want to calculate r of -1, which simply means dump the -1 in to r of x everywhere we see an x. So if we do that, we get -1 to the 4th power is 1. Minus 3 times -1 squared is +1, so it would be just -3, plus 2 times -1 is going to give us a -2, times -1 cubed would be -1, minus 2 times -1 would give us +2, and I have +3, and then we just want to go ahead and simplify that. So we get -1 minus 3 is -2, minus 2 is -4, times -1 plus 2 is 1 plus 3 is 4 equals -16. So we wind up with the ordered pair -1 comma -16. And because I've already went ahead in GeoGebra Classic 5 and graphed the situation I'm dealing with, I know that I have a check on my work. I know the point -1, -16 is the point on the graph. So I know that my work's correct. In fact, because I put the tangent line on in GeoGebra Classic 5, GeoGebra Classic 5 gave me this equation for that tangent line. And so because I did this ahead of time, if I make a mistake in any of my calculations, I'm going to know that I made a mistake and that I have something that I need to fix. So I've calculated r of -1. Now I need to find r prime of -1, which means I need to calculate the derivative of r. So r prime of x, I need its derivative. And I see that r of x is a product of two trinomials. So because it's a product of two functions, I'm going to go ahead and just use the product rule to find the derivative. So the product rule says first take the derivative of the first function. So I'm going to take the derivative dx of the first trinomial, the x to the 4th minus 3x squared plus 2x. And then I'm going to multiply that derivative by the second function, the trinomial x cubed minus 2x plus 3. So that's the first part of the product rule, which then says add to that the first function, f of x, which in this case is my trinomial x to the 4th minus 3x squared plus 2x, and multiply that by, I'm going to need to move this out of the way, multiply that by, take the derivative of the second function, so take dx of the x cubed minus 2x plus 3, so x cubed minus 2x plus 3. So now I'm going to go ahead and take the needed derivative, so ddx of this first guy. So I'm going to apply the power rule to x to the 4th. I'm going to bring the exponent down into the coefficient position and reduce the exponent by 1, minus 3 times. This is a constant multiple of a function, so it's going to be the constant times the derivative of x squared. X squared, I'm going to use the power rule. I'm going to bring the 2 down into the coefficient position and reduce that exponent by 1, plus, now I have a constant multiple of x, so it's going to be the constant times the derivative of x. But we know from the last homework that the derivative of x is just 1. and it's times the x cubed minus 2x plus 3. We don't need to do anything to that. Plus, rewrite this function, x to the fourth minus 3x squared plus 2x times the derivative of this function. Apply the power rule to x cubed. Bring the 3 down into the coefficient position. Reduce the exponent by 1 minus a constant multiple of the derivative of x. The derivative of x is 1, so negative 2 times 1 plus the derivative d dx of a constant is 0. And I can simplify things just a hair. So I'm going to get 4x cubed minus 6x 2 times 1 is just plus 2. Got to watch my penmanship here. And then I have my x cubed minus 2x plus 3 plus my x to the fourth minus 3x squared plus 2x times 3x squared minus 2. So there's my derivative r prime of x. And what I really need to know is r prime of negative 1. I need to know the derivative, the slope of the tangent line, when x is equal to negative 1. So I'm going to evaluate r prime at negative 1, which means plug negative 1 in everywhere we see an x. So I'm going to get 4 times negative 1 cubed is going to be negative 4. Minus 6 times negative 1 is going to be plus 6 plus a 2 right there times negative 1 to the third power is negative 1 minus 2 times negative 1 will be plus 2, and then I have the plus 3 plus negative 1 to the fourth power is 1 minus 3 times negative 1 squared is just minus 3 plus 2 times negative 1 will be minus 2 times 3 times negative 1 squared is 3 minus the 2. And now I can simplify. So I get negative 4 plus 6 is 2 plus 2 is 4 times negative 1 plus 2 is 1 plus 3 is 4. 1 minus 3 is negative 2 minus 2, so I have plus a negative 2 times 3 minus 2 is 1. Double check this. So there's a mistake right there. 1 minus 3 is negative 2, minus 2 is a negative 4 times 3 minus 2 is 1. And this is going to equal 4 times 4 is 16. Minus 4 is 12. And remember I said I had checked ahead of time using GeoGebra, and I should be getting 12x minus 4. So my slope calculation appears to be correct. And then this is a tangent line we're calculating the equation of, so I know that the tangent line will be of the form mx plus b if I'm using slope-intercept form. If I use point-slope form, which as long as the directions don't say use slope-intercept form, point-slope form is okay as well. But if I'm using slope-intercept form, here's what it will look like. And so I can immediately replace m, the slope of the tangent line, with the 12. And I get 12x plus b is my tangent line. And now I have to grab that point on the graph, and it says, hey, the tangent line will output a negative 16 when the function input is a negative 1. So replace the function input x with the negative 1 plus b. So I get negative 16 equaling negative 12 plus b. Add 12 to both sides is going to give me a negative 4 is b. And then finalize that tangent line formula. The tangent line is equal to the 12x minus the 4, replacing the b right here with the negative 4. And there it is. And again, like I said, I did it ahead of time in GeoGebra. That's why there's a picture sitting here. And I did that as a check on my work, so that as I get through the arithmetic and the algebra, if I make a mistake, I've got a built-in answer key waiting for me.